Yes, welcome to Vision Plus and welcome back to the S.4 Mathematics. We are looking at stationary points of a curve or the turning points of a curve. Example 4, part A says, find the turning points of a curve, and the curve is y equals to 5x minus 6 minus 8 squared. And the question should say, and distinguish them. I forgot that in the question. So this is our curve. Now we need the stationary points or the turning points of the curve. What do we know at the turning point? At any turning point on a curve, the gradient is 0. That implies that dy dx is 0. So we need to find dy dx. dy dx is the derivative of the curve. Therefore, dy dx becomes, we need to differentiate the function of the curve. So this here gives us 5x. If we differentiate 5x, it gives us 5. This minus, if we differentiate 6 is a constant, it gives us 0. Minus, if we differentiate x squared, it gives us 2x. This gives us here 5 minus 2x. This is the gradient function of the curve. That is a function that defines for us the gradient of the curve at any point. But we are saying that at the turning point, dy dx is 0. At any turning point, at the turning point, dy dx is 0. That means we need to get the values of x at the turning point for which the gradient is 0. That is the implication here. So we substitute dy dx is 0. Therefore, 0 in the portion of dy dx equals to 5 minus 2x. Here now we can find the values of x for which the gradient is 0 at the turning point. So here we need to find x. If you make x the subject of the formula here, I'm seeing that x equals to 5 out of 2. Or someone can write x is 2.5. This is the value of x. Now, since we have only one value of x, it means there is one turning point of this curve. We have only one turning point of this curve. Now, this one is the value of x at the turning point. But remember, a turning point is the coordinate point. It has x and y. Okay? That is at the turning point. It should be a coordinate point containing the value on the x-axis and that on the y-axis. Therefore, when x is 5 out of 2, we need to get the corresponding value of y, so that we have a coordinate point. So you come back and use the equation of the curve. So y becomes, wherever you see x here, we have obtained x as 5 out of 2. So we substitute for x as 5 out of 2. So here we shall have 5 x. What is x? X is 5 out of 2. Minus 6 minus x. X is 5 out of 2, but the second case says squared. Now we need to simplify this. You press the calculator. 5 divided by 2 times 5. 12.5. Here we have 12.5 minus 6 minus 5 divided by 2 squared. 25 out of 4. Or you can write it in decimal. Now we operate this. We shall have 12 minus 6 minus 25 out of 4 is 12.5. So I'm getting y as negative 1 out of 4, or somebody could be having negative 0.25. They are the same. Choose one. Now let me confirm. 5 divided by 2 squared plus 6. 25 divided by 2 minus answer. I'm again getting it as positive. Let me press again. 5 times 5 divided by 2 minus 6 minus 5 divided by 2 by the squared. It is positive. I don't know how I press it in the first case, but the second case gives me positive. Let me put in the function very fast. 5x minus 6 minus x squared. Yes, then I press calc. My x is 2.5. Yes, it is positive. So after getting x, after getting the corresponding value of y, rather, now our point becomes, our x is 5 out of 2 and our y is 1 out of 4. This is the turning point that we have. Now we have one turning point. Since we have one turning point, let us see if it is a minimum turning point, it is a maximum turning point, or it is a point of inflection. So to test, we say that we use the method of second derivative. That is, we find d squared y x squared. So you come and get the gradient function of the curve, which is 5 minus 2x, that is dy dx. We obtain it as 5 minus 2x. We need to differentiate this again to get the second derivative. And when we differentiate again, we get d squared y dx squared equals to, if we differentiate 5 is a constant, we get 0. Minus, if we differentiate 2x, it gives us 2. Therefore, 0 minus 2 is negative 2. Now, let us test our point. It is just one single point in this case. So, our point is 5, 2, and 1 out of 4. You know that this is x, this is y. So, we come and substitute for x in the second derivative function. So that you have d squared y dx squared at this value of x, which is 5 out of 2. But if you look at the second derivative, it is negative 2. It is independent of x. Okay, there is no x term in the second derivative. So it doesn't matter what the value of x is, it will always be negative 2. Okay, the second derivative is independent of x. So whether you substitute for x or not, it is the same value. It is independent of x. Now, after getting the value in the second derivative, after trying to substitute for x, for which in this case it is independent of x, you judge, is negative 2 more than 0? Is it equal to 0 or it is less than 0? Any negative number is less than 0. So, and we said that if the second derivative after substituting for x is less than 0, then the point we have is a maximum turning point. Maximum turning point, or it is a maximum stationary point. This implies that the point 5 out of 2 and 1 out of 4 is a maximum turning point. Please, you must conclude that this point is a maximum turning point. And part A only has one turning point, which we have identified as a maximum turning point. So this is the solution to part A.